A tornado is the only weather on Earth that comes looking for a single address. A hurricane hits a coastline. A flood fills a valley. A tornado picks one house on one street, takes it to the foundation, and leaves the house next door with the porch light on. So we're going to rank them. 6 tornadoes, from the one you can stand in to the one that scours the ground to bare soil, measured by one number. Not the wind speed, how many seconds that wind is actually on you. Because a tornado is not a wall you hit. It's a thing that arrives, does everything it is going to do, and leaves. Sometimes in less time than it takes to read this sentence. We start at the bottom, the one that fools you. An EF0, winds around 65 to 85 miles an hour. And here's the problem with it. You can stand in it. You can lean into it, the way you lean into a strong gust at the coast. Branches come down. A fence panel goes. It is genuinely survivable in the open. And that is exactly why it's dangerous. Because the EF0 is the one people walk outside to look at. It's the one that gets filmed from a driveway. It looks like weather you can watch. And most of the time, it is. Most tornadoes never get stronger than this. They touch down, wander a mile or two, and lift. You'd tell the story for years. Remember that this one didn't really hurt you. Hold on to it. It's going to come back at the end, and it's going to change the entire ranking. Now let's turn up the wind and watch the air stop being air. An EF1. 86 to 110 miles an hour, and somewhere in that jump, the tornado picks up its first real weapon. And it isn't the wind. It's everything the wind is now carrying. At these speeds, the air fills with debris, and debris at 100 miles an hour is no longer debris. It's a projectile. A loose plank, a length of pipe, a roof tile, each one now moving fast enough to go through a wall rather than bounce off it. This is the single most important fact about tornadoes, and almost nobody knows it. For most people, the tornado never touches them directly. The debris does. You're not mostly in danger of being blown away. You're in danger of being hit, which is why the advice is always the same. Get low, cover your head. Not because the wind will lift you at an EF1, because the air is now full of things moving faster than a car on a motorway, and the back of your skull is the thing you most need to keep. 10 seconds of that. EF1 fills the air. EF2 starts taking the building apart. An EF2, 111 to 135 miles an hour. And this is where the structure you're hiding in stops being on your side. The roof goes first, and in a specific way. Wind flowing over a roof doesn't push it down, it lifts it, the way air over a wing lifts a plane. Fast enough, and your roof becomes a wing that wants to leave. Once it does, the walls have nothing holding their tops together, and they fall outward. This is the moment all the advice is built around. Lowest floor, most central room, as many walls between you and the sky as possible. Not because any single wall saves you, because the building comes apart from the outside in, and every wall the tornado gets through first is a few more seconds it spends on the house instead of on you. It's why people are told to get in the bathtub, bolted down, low, often in the middle of the house, one more solid thing wrapped around you while everything above head height is removed. 15 seconds. EF2 takes the roof. EF3 takes you. An EF3, 136 to 165 miles an hour. And at these speeds, weight stops protecting you. A car weighs well over a ton, and people believe a car is safe. It's metal, it's heavy, it has a seat belt. At EF3, a car is a thing the tornado rolls down the street. It gets lifted, it gets thrown, and there is no version of being inside it that is good. And here is a myth that has killed people. you do not shelter under a motorway overpass. It looks like solid concrete, but the shape funnels the wind and speeds it up underneath and lifts you off the embankment. A famous old survival video is why the myth spread, and it's the exact opposite of what you should do. If you're in a car with no building near, get as low as the land allows, away from the road, and cover your head. By EF3, the shape has usually changed, too. It stops looking like a rope and starts looking like a wall, a wedge, wider than it is tall, and from the ground, you may not see it rotating at all. It just looks like the sky has gone solid and is coming toward you. 20 seconds. EF3 lifts you. EF4 is where it stops being something you see and becomes something you only hear. An EF4, 166 to 200 miles an hour. And survivors almost never describe this one by what they saw. They describe it by what they heard. A freight train, a waterfall, a roar with no gap in it. At an EF4, the sound isn't something you hear so much as a pressure you're inside of. Continuous, enormous, close. And it arrives before the worst of the wind, which means for a few seconds, you are listening to the thing about to reach you. And this is where we kill the oldest myth of all. You've heard you should open your windows to equalize the pressure so the house doesn't explode. Do not. The house doesn't explode from the inside. It's torn apart from the outside by wind and debris. And the seconds you spend opening windows are seconds you're not in the safe room. The advice was wrong. It cost people the only time they had. At EF4, you also see the tornado's strangest signature. It is not uniform. Inside the main circulation are smaller, faster vortices whipping around the center. One can level a house, while the one beside it keeps its walls. It's why survivors say it felt personal. It wasn't. The tornado is not one wind, it's a nest of them. 30 seconds. EF4 is the sound. EF5 is the silence after, because there's nothing left to make noise. An EF5, over 200 miles an hour, the top of the scale. And the way meteorologists describe the damage isn't technical. The original scale called it simply incredible. At EF5, a well-built house is not damaged, not destroyed. Removed, swept off its foundation, the foundation left bare, as if the house had never been built. Cars are thrown not down the street, but across fields. Tarmac is peeled off roads. Grass is pulled from the ground. In one tornado near Oklahoma City in 1999, radar measured winds near the surface above 300 miles an hour, among the fastest ever recorded anywhere on the planet, faster than most of what happens inside a hurricane, a few meters above the ground in a suburb. And this is where the safe room stops being a guarantee and becomes a probability. The advice doesn't change. Lowest floor, most central room, cover your head. But at EF5, the honest version is that survival depends on whether one of those inner vortices passes directly over your address, and that isn't something you choose. Underground, or a purpose-built shelter, is the only thing that reliably works. Up to a minute of that. That's the top of the ranking. Winds that scour the earth. And now, watch what happens when we rank the exact same 6 by something else. So, ranked by strength, that's a breeze you can stand in at the bottom, and ground scoured to bare soil at the top. Now watch what happens when we rank these 6 by how many people each one actually kills. The EF5, the incredible one, the one this whole video has climbed toward, kills, in most years, almost nobody. 3 reasons. It's staggeringly rare, a fraction of 1% of all tornadoes. It's almost never a surprise because the storms that make one are watched for days. And when the warning comes, people take an EF5 seriously. They go underground. They leave. And then you get to the bottom, the weak ones. The EF0 and the EF1, the tornado you could stand in, the one people film from the driveway. Those kill the most people, every year, by a wide margin. And once you see why, you can't unsee it. There are hundreds of times more weak tornadoes than strong ones. Nobody evacuates for an EF0. Nobody goes underground for a storm that looks survivable, because it is survivable in a well-built house, which is exactly why people don't respect it. And the debris doesn't care what number is on the tornado. A plank at 90 miles an hour goes through a wall the same whether it came from an EF1 or an EF5. And now the single most important fact in the subject. Where you are matters more than which tornado you get. A weak tornado over a mobile home is far more lethal than a strong one over a house with a basement. In the United States, people in mobile homes die in tornadoes at many times the rate of people in permanent houses from tornadoes a solid building would have shrugged off. And one more thing, darkness. A tornado at night is far more likely to kill you than the same one in daylight, because you can't see it coming, because you're asleep, because the warning arrives and you don't wake, or you wake and don't move. The deadliest tornadoes in your lifetime won't be the strongest. They'll be ordinary ones, at night, over people who never got up. That's the inversion. The strength ranking is upside down. So here's the ranking that actually matters, not the wind. The walls. Because the tornado is the one thing in this story you cannot change. Not its rating, not its path, not whether an inner vortex passes over your address. Every variable that to the building you're standing in, and whether you believed the warning enough to be in the right room of it. That's why every piece of advice in this video collapses to one sentence. Put as many walls as you can between yourself and the sky, as low as you can get, before it arrives. Because once it's on you, there's nothing left to decide. The whole game is played in the minutes before, by people who took a survivable-looking storm seriously enough to move. Which brings us back to the one at the bottom, the one you could stand in, the one that didn't hurt you. It's the deadliest tier on the list, not because it's strong, but because it isn't. And that's exactly what makes people walk outside to look at it. A tornado picks one address, but which house it takes isn't luck, not entirely. It's the walls, the floor beneath them, the room you chose, and the 90 seconds you spent getting there instead of watching. You spent 14 minutes climbing toward the strongest wind on the planet. But the strongest wind was never the thing most likely to kill you. It was the small one, on an ordinary night, that nobody got up for. If you made it to the top of the scale, subscribe. Next time, you're in a crowd that stops moving, and we count every person per square meter until you can't breathe.